We're starting chapter 6 today. Chapter 6 is all about systems of equations. Systems of equations. Goals for today, we are going to define what a system of equations is, as well as talk about what its solution is. Eventually, not today, but eventually we'll be solving a system of equations. Today we are just going to talk about how to tell if something is a solution or not. So we're in section 6.1. 6.1 is on verifying solutions to systems of equations. Verifying solutions. Let's start with a little bit of vocabulary, starting with a system of equations. Everything we do will be a system of linear equations. A system of equations is two or more equations with the same variables. Two or more equations with the same variables. Linear equations, everything we've talked about has been a linear equation. That is an equation whose graph is a line. So we are going to have two or more linear equations with the same variables. Often x and y, don't have to be though, a and b, s and t, m and n. Two or more linear equations with the same variables. And then the solution to the system is any ordered pair in a system that makes all the equations true. And the word all there is important. In order to be a solution to the system, it has to make all the equations true. If there are any equations that are not true, that ordered pair is not a solution. Remember, ordered pair is an x and a y, written like this. This is my x and this is my y. That is an ordered pair. The solution to the system is an ordered pair that makes all the equations true. If I'm ever going too fast, feel free to pause the video so everybody can get the notes written down, and then you can restart. Example 1 wants to know, is the point 3, -4 a solution to the system? This is our system. A lot of times you'll see these curly brackets written over here to show that those two things are put together. You don't have to have the curly brackets, but often you will see them. Is 3, -4 a solution to that system or not? And then the solution says x plus y equals -1 and y equals 2x minus 10. X plus y equals -1, y equals 2x minus 10. So what we need to do is we need to take our point, 3, -4, and plug it in for x and y. And we're going to start with the top equation. So I'm putting 3 in for my x and -4 in for my y. So it's going to say 3 plus -4 plus -4 plus negative, remember that's the same thing as minus, equals -1. And we want to decide, is this a true statement or is this a false statement? 3 minus 4 is indeed -1. So it works in the first equation. Remember, that's not enough to say that it's a solution. It has to work in all the equations. So now we're going to take the x and y and plug it into the second equation. Y equals, so -4 equals 2x, 2 times 3 minus 10. I put 3 in for my x and -4 in for my y. 2 times 3 is 6. 6 minus 10 is indeed -4. I again get a true statement. This point, this ordered pair, works in both equations, so yes, it is a solution. It has to work in both. Example 2. Is -2, 1 a solution to this system? Is -2, 1 a solution to the system y equals 2x plus 5 and y equals negative 3x minus 2. Is negative 2, 1 a solution to the given system of equations? Again, we are going to take our point. X is negative 2, y is 1, and we are substituting into the first equation. 1 for my y, negative 2 for my x. Two times negative 2 is negative 4. Negative 4 plus 5 is 1. It works in the first one. Just because it works in the first one does not make it a solution. We have to check both. So I'm going to the second equation. I'm putting 1 in for my y and negative 2 in for my x. Negative times negative is positive. 3 times 2 is 6. 6 minus 2, that's 4. 4 is not equal to 1. So I have it working in the first equation, but not in the second. It has to work in all of them to be a solution. This is not a solution. On a problem like this, if this is on a test or a quiz, when this is on the homework, just putting yes and no is not going to give you any credit. You have to show your work. You have to verify if it is a solution or not with the appropriate work. Number 3, example 3, is the point 3, negative 4 a solution to the given system? Is 3, negative 4 a solution to the system? X plus 1/2 y equals 1, and y equals 2x minus 10. Is 3, negative 4 a solution? So my x is 3, my y is negative 4. 3 in for my x, negative 4 in for my y. 1/2 times negative 4. Positive times negative is minus. 1/2 of 4 is 2. 3 minus 2 gives me 1. It works in my first one. Check it in the second one. Negative 4 equals 2 times 3 minus 10. 2 times 3 is 6. 6 minus 10 is negative 4. It works in the second one. If it works in both, yes, it is a solution. This last example problem is for you to try. I want you to find if 0, 6 is a solution to the given system. Is 0, 6 a solution to the system? So what I want you to do, go ahead, pause the video. I want everybody to try the problem on their own. Once everyone, or at least most everyone, has it completed, then you can play the video and we'll see the solution. One third x equals y plus 6. We're plugging 0 in for x and 6 in for y. 1/3 times 0 is 0. I get 0 equals 12. 0 is not equal to 12. It did not work in the first equation. We don't even have to check the second one. If I find any that it doesn't work in, we can stop right there and say no. You should find that it did work in the second one. That doesn't matter. It has to work in all of them. As soon as you get one that it doesn't check, the answer is no, it is not a solution.